Hey, Miss Marion here. We are going to go over Unit 1, Lesson 9. And again, we're talking about geometric meanies and figuring out how to find different pieces. So our learning target is I am learning how to find missing terms in a geometric sequence. Our success criteria, I got it when I can find missing terms in a geometric sequence. So this is our goal for today. Make sure you have a workbook or a piece of paper to go ahead and write this down. And we're going to go ahead and start learning. All right, so today's puzzles involve finding missing terms between two numbers in a geometric sequence. So what information do you think will be useful for finding missing terms in the geometric sequence? How do you predict the methods for finding missing terms in the arithmetic and geometric sequence will be similar? And then how do you think the methods will be different? So we're going to kind of cover all of these different things, kind of keep this in your mind, back of your mind. But this is actually what we're going to be covering for today. All right, so here is number 1. So each of the tables below represent a geometric sequence. Find the missing terms in the sequence itself. So we are actually on page 83. And so go ahead and figure out what that missing piece would be. So pause this and then come back to me. All right, so what we actually really want to find, we want to find what is called the common ratio is really what we're looking for. And a common ratio is actually for a geometric sequence. A common difference is for arithmetic, and that's adding or subtracting. Ratio is the geometric, because a lot of times we have to multiply or divide by something to figure out how to go to the next term. And so what we want to do is, I'm sitting here thinking, okay, I'm going to take 3 and I'm going to multiply it by some type of ratio to get that middle piece. And then I'm going to take that middle piece and I'm going to multiply it by the ratio again to get 12. So, okay, so I have this 3 and I have this 12. So I'm going to take this last term and I'm going to divide it by 3. Okay, so I'm going to say, okay, I have 12 divided by 3, which is 4. So this is kind of, in a way, the geometric or the common ratio. And so I know we're going to have a 4. So really what I have to think about is I took that ratio and I multiplied it twice to get the 4. So I have to think about, okay, what number multiplied by itself makes 4? Well, okay, that number is actually 2. So the common ratio that we're looking for is actually 2. And then, but my other question is, so, okay, let's try it for a second. So if I take 3 and I multiply it by 2, this inner piece is 6. And then if I take 6 and I multiply it by 2, I'm going to get the 12. But my other question is it only 2 that's going to be our answer? Is there any other answer that we can actually go ahead and still kind of, could I put a different number in here and still get 3 something and then 12? And then also have a common ratio. So I know it probably has to deal with something with the 2. And I'm going to ask, could the common ratio be -2? Could I take 3 and multiply it by -2 and get -6? And then can I take -6 and multiply it by -2 to get the 12? And that answer is yes. So notice I can either have 6 or I can also have -6 sitting in this middle term. It didn't tell me if I had to have it positive or negative. So I'm going to say our common ratio is 2. And then I'm also going to say, okay, it's 2, but it's also -2. So 2 and -2 will let me go ahead and start with the 3, fill in that missing term, and then get a 12. All right, so here is example number 2. So we are on page 84, on page 83. And here's example number 2. So go ahead and see if you can figure out the missing pieces. So pause, go figure that out, and then come back to me. All right, so I have this 875, and I have this 7, so I'm kind of starting with 7, and I have to kind of split it into 2 different pieces. So I'm going to kind of change it, so I'm not starting with the 7. So I'm going to take 875, and I'm going to divide it by 7 and get 125. Okay, so that's going to kind of help me. Remember, I'm going to take my 7, I'm going to multiply it by a common ratio. Take that one, multiply it by common ratio, and take that one and multiply it by common ratio to go ahead and fill in the rest of this table. So I took my ratios and like the difference, I guess the difference of the 3 in there is the 125. And remember, we're multiplying, so you can't do it as the same as arithmetic like yesterday. But I know I took that ratio, I multiplied it, a number, multiplied by itself 3 times, and we get this kind of common difference of 125. So I'm going to think about it for a second. Okay, so what number multiplied by itself 3 times would make 125? Oh, that's 5. So I'm going to sit there and think, okay, my common ratio is 5. Let's try it. Let's do 7 times 5, and that will make 35. And let's take 35, multiply it by 5, grab a calculator. All right, that's 175. And then let's take 175, multiply it by 5, and that makes the 875. Ooh, that does work. Okay. But last time we said, oh, it can be 5, or last time it was 2 and negative 2. Let's try it with negative 5. So let's take 7, let's multiply it by 5. We're going to get negative 35. Let's take negative 35, multiply by negative 5, and we get positive 175. And then we're going to take that positive 175, we're going to multiply it by negative 5, and that gets negative 875. So does a ratio, the common ratio of negative 5, does that work? No, it does not, because I want a positive 875, but it makes a negative 875. So the common ratio this time is only r equals 5. So hopefully you can kind of see a pattern going on. And let's go ahead and figure out number 3. All right, so here's number 3. Figure it out. And so we are still on page 83. We find the missing pieces and then come back to me. All right, so if we think about it, we're going to be multiplying by that common ratio 1, 2, 3, 4 times. But again, I kind of want to kind of change it because we have the 6. So I'm going to take 96. I want to divide it by 6. Kind of figure out that difference that's along with it. And we get 16. So we have a number multiplied by itself. And we multiplied 4 times to get the 16. So that should actually equal 16. All right, so what number multiplied by itself 4 times makes 16? Okay. All right, so I think that common ratio is 2. So let's take 6, multiply by 2, and we're going to get 12. And we're going to take 12, we're going to multiply by 2, we get 24. We're going to take 24, multiply by 2, we get 48. And we're going to take 48, multiply by 2, we get 96. Haha, that works. Okay. But the first one, it said it was 2 and negative 2. Let's try it out. Let's see if it works for this one. So we're going to take 6, we're going to multiply it by negative 2, we get negative 12. Then we're going to take negative 12, multiply it by negative 2, we get positive 24. Okay. And then we have positive 24. We multiply it by negative 2. We get negative 48. And we're going to take negative 48, multiplied by negative 2, and we get a positive 96. Okay, so this does work. So our common ratio is 2 and negative 2. Okay, so the last one didn't work because the common ratio was multiplying 3 times. But the one before, the common ratio was multiplying 2 times, and it did. And this one worked 2 times, and it did too. Okay, well, let's keep this in mind. All right, still on that page 83, try example number 4. See if you can kind of see that pattern. So pause, go ahead and come back to me. All right, so we are multiplying 1, 2, 3, 4, 5 times. I'm kind of still, I have this 927. We're going to divide it by 4. And we're going to get 243. Okay. So that's kind of, I guess, the difference between the 4 and the 972, and it's geometric, and we're multiplying, so that's why we divided it. But then we have this 243. I know the R is being multiplied for 5 times 243. So what number multiply it by itself 5 times? Let's try 2. All right. 2, 2, 3, 4, 5. Nope, that's 32. Let's try 3. 3, 3, 3, 3, 3. Oh, that is 243. So we're saying our common ratio is 3. Okay, so let's fill in our stuff. So we're going to say 4 times 3. We're going to get 12. 12 times 3. We are going to get 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. And then 324 times 3 is the 972. Okay, let's try it with the negative 3. All right, so let's do 4 times negative 3 is negative 12. Negative 12 times negative 3 is 36. 36 times negative 3 is negative 108. Negative 108 times negative 3 is 324, positive. Negative 324 times negative 3, or sorry, that's positive 324 times negative 3 is negative 972. All right, so does the negative 3? All right, so then our common ratio is only just the 3. So let's kind of explore some stuff. This is on page 84. It says, describe your method for finding the missing term in a geometric sequence. So I actually have 4 steps that I've been following. So 1, I divide the last term by the first term. And then pretty much what I'm doing is I'm counting the number of jumps between the first and last term. Number 3, I kind of think about it as our common ratio is like how many times we're doing our multiply our common ratio together to get like our number. So I guess in a way we can divide the last term by the first term. Let's label that as B. Count the number of jumps. Let's label that as N. So if we really want to think about it and write it, we are writing our ratio. It's being multiplied N number of times, and that's going to kind of equal our division number. And then what we're doing is we're thinking about how many times the number, so how many times is the ratio multiplied together to make the division number, the B. So, and then if you kind of think about it, we're really kind of looking at like square roots and cubed roots, but we're looking to see with that B, how many times the number, what number multiplied by itself, so many times will make that letter B. So I don't know how to put that in a sentence, but that's kind of what we're doing. And then number 6 says, how can you tell if there will be more than one solution for the missing term? And if you haven't figured it out yet, it's kind of as follows. So if N is even, right? So how many times we multiply that common ratio together is even the ratio, which is R, could be positive or negative. And if N, the number of times we multiply the common ratio together, is odd, the ratio is only one possible answer. Okay, so again, if we take that ratio, we multiply it 4 times together, then it could be positive and negative. If we take that ratio and we only multiply it 3 times together, then it's only one possible answer. So this is kind of how we know if we're going to have more than one answer to go along with this. All right, so some takeaways. To find the missing term in a geometric sequence, we're going to take the first term and pretty much we multiply it by R, which is the ratio and the number of jumps. So and it is going to equal our last term. So we kind of did it backwards before. We took our last term and we divided it by the first term, and that gives us a number that we have, and then how many times we multiply that ratio together will equal that number. And then if we look at it, we can take our first, so f of 1 times r n to the minus 1 equals f of n. So this is our way of actually figuring out how to go ahead and figure out what our missing pieces are. And this is our equation that we can actually go ahead and use. So I would write this actually down underneath our takeaway piece. All right, so this is what we're doing for today. We're finding that missing pieces as far as the geometric sequence. We're finding that common ratio on our geometric sequence. But yes, we're going to go ahead and do a check our understanding. We're doing the ready, set, go. And you can find that in Canvas. Have a good day. Thanks, bye.